Hi, my name is Peter Dufresne from EPT Clean Oil, and I'm excited to be bringing this week's episode of In the Middle from Muscat, Oman. I'm here with my colleague.
Hi, this is Khashayer Haji Ahmed, Business Development Manager for EPT Clean Oil. We are excited to record this session for you.
You know, I've talked to a number of people in the industry, and when their bearing failure does occur, I'm not sure that they actually step back and identify the cause of that bearing failure. What is your perspective on this?
Generally, in the first couple of hours, everybody is running into bringing up the machine back to work, and it can get up to a couple of hours into a day, bringing up back the turbo machinery bearing failure. But then, generally, everybody, after that one day of heat and stress, they will be looking at the root causes, but journal bearing failures are not standardized as a method for failure analysis. So this knowledge is scattered here and there.
So you're saying if it was a roller element bearing, there would be a predetermined method to determine the cause of failure.
Exactly.
But in the journal bearing application, that doesn't exist. Okay. That's sort of consistent with what we've seen. Can you tell us about temperature sensors on journal bearings themselves? Like, are you able to actually measure the temperature of a journal bearing, or is the location of the temperature monitoring really not indicative of the actual bearing temperature, say if you had a deposit on that bearing?
Yeah, it is generally very close to the shell.
Okay.
But not measuring for sure asperity level temperature, but it will be a condition where internally journal bearing is heating up. Finally, you will be checking it in the housing, you will be getting that temperature. But the point is that they are being measured trending 24/7, and then a peak happening in the heat. It is quite a natural presence of varnish on the journal bearing surfaces.
So why do they get that peak on the temperature sensor?
Because the film of lubricant film, it should be making a wedge.
Yes.
This wedge is not being formed due to the deposits formed by the lubricant.
So why isn't the temperature peak then consistent all the time? Why is it just going up and then it goes back down? What is the nature of that driving that?
This is a good question. My perspective is that because of varnish is changing its presence, soluble varnish and insoluble varnish, sometimes you have a layer of varnish deposited, and then temperature changes, flow changes, pressure changes, causes it to dissolve back to the lubricant.
Okay.
So it's not a consistent layer of varnish all the time. So by the load changes, temperature changes, speed changes, you will have this layer moving on the bearing. Then you have peaks in the certain time of the day when it is hot. Certain part of the seasons, these bearings will be showing more heat.
Okay. So I guess one thing I was considering, why does the oxidation material in the bearings, why does it deposit on the bearings, for example?
The bearings are the support.
Okay.
So the load is being transferred there for any rotor. So this high load is stressing the lubricant, and as well the heat which is happening over there. So this heat and load, and as well as presence of oxygen, they are creating an environment, the lubricant to be saturated, and then on the spot, because of these changes of load, speed, and temperature, all of a sudden depositing on the location where you have a very low clearance on the bearings. Could be other mechanical parts of the system, they have higher clearances, so they are not making troubles, but in the bearings.
Is there anything chemically going on that would, say, attract contamination in the oil towards the bearing surface?
Yeah, this is about polarity. I mean, you are an expert of the field. I learned it from you. So polarity is something about lubricant, which lubricants in turbine and compressor applications, they are non-polar. And then oxidation material are polar. And then close to them, next to the oil, they are the neighbor, metal surfaces, they are polar. So they invite these molecules to be attracted to them, attached to them very fast. Wherever oil is in touch, this material can be deposited very fast.
Okay.
And then, because of the less clearances in bearings, we see them depositing there and then causing mechanical problems.
So these clearances that you're talking about, what are they, the predetermined clearances on, say, a journal bearing application?
It depends on the size of machine and the design, but they are generally between, let's say, 20 micron to 100 micron in design.
Okay.
It depends on the criticality of the application and the design, but they are into this range.
Okay, and that's well within. How thick is the when you look at a varnish deposit, how thick would that be on the bearing?
You can touch it with your hand and you can see it. Okay. So it is above that limit.
Well above 100 microns.
Yeah.
Okay. Well, that's good. Well, thank you for sharing with me some of your knowledge today about
Thank
bearings.
you very much for listening to us.